Number 55 was a word problem that was assigned to us. It may look tricky to you because there are fractions, however, the calculator does allow you to enter those values. Okay. So if we take a look carefully, the height of the ball in feet of a punted football is approximated by the following function, where x is the horizontal distance in feet from where the ball is punted. Y is going to be the height. So if I look at the drawing that we had from here, here's your x-axis, here's your y-axis. This is the maximum height location. Please note in the drawing that this is a vertex of the parabola. It is the maximum height. This was height. This was distance. Okay? This was known as x. This was known as y using the variables that were given to us. Okay? Use a graphing utility to graph the path of the football. There were some questions about how to enter this into the calculator. So we go into y equals, and we're going to use a parenthesis in my case, negative 16 divided by 2025 x squared plus 9/5 x plus 3/2. Those of you that stack fractions, just make sure that you are putting the x not in the denominator. Okay. Then we look at the graph. My calculator was set up from the last problem that we did. So I'm going to choose Zoom 6 just because. You're going to start to see the football. Now we know that the path of the football doesn't exist over here in the real world. This is where the football is first kicked from. This is 0 right here. So from here we can think about the window setting. If we start maybe at negative 10, let's go up to 100 for 100 yards. That's a pretty big punt for those of you that don't know. We can also change the height. Maybe the highest value would be 100 feet. And look back at the graph. Now, the first question they ask is, how high is the football when it is punted? Okay. In the story, it's going to be the start of the graph, which is here. Right there. Right? Right here? So if that's the case, find y when x is 0. So that means we're looking for this. So in part B, we're looking for x is 0, find y. That in this case is the y-intercept. Given the fact that we were given general form, the y-intercept is going to be 3/2. So in other words, 1.5 feet high was the height of the punt off of the ground. Part C, what is the maximum height of the football? Okay, well to figure out part C, we can use the information here and use our formula. So our formula says negative b over 2a is going to be the x value of that. So that is negative 9/5 over 2 times 16 over 2025. This is a complex fraction. So you're looking at negative 9/5 divided by 32 over 2025. We can actually go to our calculator to do this. If we were doing this by hand, take a look at this work. Notice negative b over 2a is here, negative b over 2a, comma. Then I took the top, left it the same, simplified the bottom fraction, got to here. So here's our overall fraction situation. I would take negative 9/5 times this, or I can go to my calculator and let it do the work. So I can say negative 9/5 divided by, going back to this statement here, 32 divided by 2025, and then I'm going to ask it to give me my answer as a fraction, option 1. this is what I get for my answer. So at negative 3645 over 32, negative 3645 divided by 32, also known as approximately 113.91 feet. We go back to our signs. This is a negative, this is a negative, this becomes a negative over a negative, which then becomes positives. So that's where I'm getting my final answer. Here. The last question, this is going to be the distance along x. So they want to know the height, so we're going to take this and plug it back into the original problem up at the top. Okay, 113.19. So we can put in negative 16 back. Let's put some parentheses around that. Negative 16 divided by 2025 times, we'll use the 113.91 if you want, squared plus 9/5 times 113.91 plus 3/2. .15 is my height. The last question that you're asked is, how far from the punter does the ball strike the ground? So they want to know this distance that I'm writing in. From here, which is where the ball is kicked, all the way over to here where it then strikes the ground. By definition, this is an x-intercept. What do we know about all x-intercepts? So this is part D. X-intercepts have y equal to 0. Substitute up top. 0 is equal to negative 16 over 2025 x squared plus 9/5 x plus 3/2. If you think back to the other example that we had, you could convert all of these to decimals, use them as the a, b, and c values, and plug them into the quadratic formula. When you plug them into the quadratic formula, by taking what's out front, plus or minus the root, it's going to take you one direction or the other. We want to figure out this distance.